guys, hope you're doing great. Today's question is symmetric tree. Given a binary tree, check whether it's a mirror of itself, that is symmetric around its center. For example, this binary tree, if you see this 1, 2, 3, 4 and 2, 4, 3. But so this one is a symmetric tree. Reason being, if you flip it, right? So if you just kind of flip it, so it should still be the same. And for example, if we try flipping this 3 would come here, this 4 would come here, right? And this 3 would go here and this 4 would go here. So in that case, even if we do so, it will still remain the same. And since here also, if we flip this tree, this 2 would go here and the other one would come here and it would still be the same, and this is just the root, so it will be the same. So if we basically move it by 180 degrees around the center, is the tree still the same? That's what a symmetric tree means, right? So talking in terms of the tree, the left and the right of any particular node, right, they are same. And then if you look at this is the left of the subtree that 2 has, and this is the right of the subtree that 2 has, and it also should be the same. Okay, so this is another example. In this case, as you can see, this is not a symmetric tree, because although it appears to be, when you will flip it, it would not give you same halves of the tree, right? So that's why this is not. So let's have a look at the number of ways we can use to solve any question on trees. Okay, so there are different ways in which you can solve this question, but typically when you have a problem where you need to divide it into sub-problems, which are like smaller problems, and if they are true, then the bigger problem is true. So for example, if the subtrees are symmetric, only then the entire tree is symmetric. So whenever you have such problems, recursion is always a good way to go, and especially with trees, there is a set of problems that by practice you will identify, which are really easy and quick to code and very, very easy to understand if you understand the concept of recursion and how to apply it to trees just once. So we'll just try solving this by recursion in this question. Okay. So as I was just talking, we saw that if any particular tree needs to be a mirror or a subtree needs to be symmetric, then the left subtree should be the mirror of the right subtree, and the right should be the mirror of the left, right? So what we'll do is we'll just write a mirror function which will check that, and we'll just call that on root comma root, right? So we'll just treat root as two different trees, and we'll just try to find if they are symmetric or mirrors of each other by taking one as it is and by taking the other one the opposites of this one. And if they all turn out to be same, we can say that it is symmetric. So it will get better with the code. So from here, all we have to do is, so just pass root comma root as I said. Okay. Now we just create this method called isMirror. Okay. And we assume that this has two different trees, root 1 and root 2. So if you get another, this actually you can use this to solve more than one question. If the question also is around whether to find out whether two different trees are mirrors of each other, this is going to be exactly the logic that you need to apply there, except for using those two different roots, right? Okay. So first of all, if one of them is null, right? If one of them is null and one of them is non-null, then it clearly means that they are not a mirror. and in that case we want to return a false. So we'll just do those checks first. So if both of them are null, then we are good, right? Because that's still equal. So we'll just return true. Okay, because this could happen to one of the set of leaf nodes of some two subtrees, right? In the recursion stack. So in this case, we just have to return true. And otherwise, if one of them is null, okay, or this. So if both of them are null, then that will be captured in the above condition and it will be returned true. After that, we just want to check that it should not be the case that either of them are null and the other one is not. In that case, we'll have to return false because they are, one is non-null and one is null. So we just have to return false. Okay. And then we compare their values and just create one statement which will be all that we need to, right? So what we'll do is that root1 dot value is equal to root2 dot value. So if they are non-null, their values should be equal. And right, so we just call this method again on the subtrees, right? So what we do is that we take the left of root1 and which should be a mirror of, yeah, the right of root2, right? And okay, let's mirror root1 dot right and root2 dot left. Sorry. Okay, so what we have done is that we have basically, so the part where we were like twisting the entire tree, right? And then comparing. So what we have done is that we are comparing the two extremities. So the left of this is equal to the right of this, and the right of this should be equal to the left of this. That is how it will be symmetric, right? So that's the logic that we have applied, and it just returns, and we just return whatever the recursive output of the entire thing is, right? So let's see if that works. Oh, okay. Uh, okay. Yeah, makes sense. Root 2. Okay. Yeah. Cool. So the time complexity for this is O of n, and the space complexity is O of n as well, because we are using recursion, and the recursion stack has an O of n time space complexity of its own. So I hope you found this helpful, and if you did, please like, share, and subscribe. Keep coding and take care, guys.